All right, welcome to the first set of these little short videos that I'm going to be doing that will help you prepare and review for some old-fashioned terms so that you can be more comfortable with the words that we're using in class and some of the ideas that we're dealing with. So hang in there with me. The nice thing, don't forget, you can pause, rewind, fast forward if you're bored. You don't need to go right to the end and don't feel like you have to watch these. So today's little first video here is about atoms, elements, molecules, and compounds, and kind of the different ways that these words can get used because it can be a little bit confusing. So first thing, since we're talking about science here and we're talking about chemistry especially, we have to define the term matter because it's kind of an important idea for us in science. We use it all the time, but we forget to define it sometimes. Super technical definition for what matter is. It's the word stuff. If you can call something stuff, then it's probably matter. If you can't call it stuff, then it's not matter. It's a really good way to kind of tell, in terms of what you think it is or not. So anything you can touch, see, feel, taste, etc., the tables, it's all stuff, it's all matter. More scientifically, more technically, matter is something that has mass and something that takes up space. So there's a few things listed on the screen there, things that aren't technically stuff, so they're not actually matter, things like light and energy and heat, which is a form of energy, or vacuum. I'm not talking about the vacuum for your living room, but the vacuum meaning the absence of stuff like in space. That's not actually stuff. So when we're talking about in chemistry, we can say that chemistry is one of the sciences of matter. And in order to talk about matter, we have to talk about atoms. A-T-O-M-S. Atoms are the smallest things that are the unit of matter in general. It comes from some old Greek words that you can see there on the screen. It's very similar in concept to the idea of a cell in biology, where we can say that the cell is the smallest unit of life. An atom is the smallest unit of matter, the smallest unit of stuff that's out there. However, you got to be a little careful because cells are much, much larger than atoms. Atoms are so tiny it's hard to believe. I think there's about 10 trillion cells in the human body. You can Google that if you want to. But then there's about 10 trillion atoms in a cell. So we're talking on an incredibly small level here in chemistry, much smaller than the biologists talk about. And just like in cells, we can say cells can be made up of smaller things like organelles and mitochondria and all that kind of stuff. Atoms can be broken down further, and we'll talk about that later on in the year. So we can talk about the parts of an atom like protons, neutrons, and electrons, but those things themselves are not atoms. So atom is going to be the smallest unit. That's kind of that key idea of what a nugget of matter would be, called an atom. So with these, we now know, obviously by looking around you, that there's lots of different kinds of stuff in your world, in your universe, things that you've learned about. We know that all atoms can't be identical because all of these different things are made up of atoms. Therefore, there must be some different kinds of atoms that are out there. You may have heard of the little cartoon there, the ancient four elements. They used to think there was 4 different kinds of atoms. There was air, there was water, there was earth, and then there was fire. Kind of onto the right idea, although we now know there's a lot more than that. Some of those aren't even really matter, like fire isn't really matter at all. And earth is made up of lots of different kinds of atoms. So today we now know that there's about 90 natural elements, which are different kinds of atoms, about 118 total. So we've discovered some, when I say 90 modern elements on the screen, I mean naturally occurring on Earth, but we've created 30 more roughly in laboratories that are definitely synthetic ones. So atoms and elements. Atoms are the smallest unit. Elements are different kinds of that sort of stuff. So you've seen this before, and if you haven't, you will a lot here very soon. The periodic table of the elements is basically our way of organizing all of these different kinds of atoms that are out there. So each square on the periodic table is a different type of an atom, and those things are called elements. Each one has its own unique number, so we can identify them, and every one of them has its own unique name and a symbol of 1 or 2 letters. So again, there's some things that are really common things in our environment that are not on the periodic table of elements, like air and water and table salt. So there's things now that we can kind of get to that next level. We can start to talk about combinations of different kinds of elements. So elements are unique types of atoms, and those things are all listed on the periodic table. So how do we go to this next step? We know that atoms can then, or different kinds of atoms, elements, can then combine to make new different kinds of stuff. This is through the process of chemical reactions. We'll talk about plenty of chemical reactions later on. But a compound is kind of what is formed from these combinations of different elements. So a compound is defined there on the screen as 2 or more different types of elements that are bonded together, and that bonding part is important. They have to be glued together in a really specific way. And if there's 90 naturally occurring elements, 118 total. There's almost an infinite number of possibilities in terms of the numbers and types of compounds that are out there. And that gives you kind of the idea of all the different things that are in our world are made of these different kinds of compounds, different combinations of elements. There's a couple of examples here of two very common elements, compounds that are out there. So water, for example, as you know, is H2O, we call it all the time. It's 2 hydrogen atoms and 1 oxygen atom bonded together. Versus table salt, like you put on your French fries, is made of 1 sodium atom, sodium's a different element, and 1 chlorine atom bonded together. So I like to think of atoms and elements and compounds, all these different words, kind of the Lego analogy. I don't know, I guess I didn't get to play with them enough when I was younger. I tend to think of an atom as being 1 Lego. And you can look at my little pile of Legos that's there. There's a bunch of different atoms there, but if you look closer, there's also a bunch of different kinds of atoms there. So you can think about the different types of Legos that are present would be, say, different elements. So I can see there's a number of those yellow 4 square type ones. That would be 1 element versus the white 4 dot stud, I think is what they're called. The little white ones versus the orange ones versus the red one. Each of those different types of Legos would be a different element. So I'll let you kind of, you can pause if you want to, but think about how many different elements are actually shown on there. And yes, a different sized red Lego would be a different element. So there's a 2x4 right in the middle, a big 8-stud brick, and then right below it there's a 2-stud brick and a 1-stud brick. They're all red, but they're 3 different elements, even though they share the same color. So moving on from this analogy, here's my kind of silly key to chemistry with Legos. I have over on the left there, I don't know, 8 different kinds of elements that are out there, each of them with a 2x4 brick of different colors except for hydrogen, which is smaller. And we can bond those things together by sticking them, just combining like you'd normally play with Legos. And so that bonding process, even though that takes a reaction, that's reversible, but it is pretty durable. Once we stick those things together, they tend to stay stuck. They don't really want to unstick themselves. And these new things that are produced by these stuck together Legos are what we call molecules. The molecules are the individual units of a compound. So at the bottom you can see 4 different compounds that are formed. There's carbon dioxide, CO2, there's H2O, water, N2, which is nitrogen gas, and O2, which is oxygen gas. So those are our 4 different compounds, and there's 1 molecule of each one that's shown on that diagram over there. So again, there's a variety of different ways we can do that. Most molecules are compounds like CO2 and H2O, where they're different things stuck together. There are some elements like nitrogen and oxygen. We call those diatomic, because there's 2 atoms. But there's some of those gases that are also over there too that form molecules. And again, a molecule is 1 or 2 or more atoms stuck together, bonded together. So here's a quiz for you. You can hit pause on this and see how you do with it, but the question I have for you is, in this picture of Lego chemistry, how many atoms are present, how many different elements are present, how many different molecules are present, and how many compounds are present. So go ahead and hit pause, and then we'll come back and talk about the answer here in a second. So hit pause right now, don't cheat. Okay, so there's your answers. In this picture we have a total of 15 different atoms, because that's 15 different Legos that are pictured in there. There's a total of 6 different elements, and again, those are the different colors or sizes, I guess, of Legos that are present. So there's hydrogen, which is white. There's oxygen, which I believe is red. There's carbon, which is black. There's sodium, which I think is green, and chlorine, which I think is yellow, or vice versa. And then there's calcium, which would be gray. So again, there's 6 different elements, 6 different kinds of atoms that are present. Molecules, again, is a cluster of atoms stuck together. So there's 1, 2, 3, 4, 5 different molecules present. But there's a total of only 4 compounds. Why is there only 4 compounds and 5 elements? Because there's actually 2 molecules of the same compound, NaCl. There's 2 of them that are present there. Okay, so a lot of times in chemistry we need to represent these not with Legos, but with little circles instead. It's a lot easier than trying to draw Legos. We call these atomic level diagrams. And rather than trying to draw something complex, we usually draw a circle for a single element, sometimes different colors or sizes for the different elements that are there. And then we kind of stick the circles together, literally have them touching one another, to represent a molecule or a compound. And again, they've got those connected circles on there. Here's your last quiz. Take a look at some of these atomic level diagrams or molecular level diagrams, and again, you'll have to hit pause and take a few seconds to think about this. There are 8 different pictures that are shown, and for each picture, which of the terms at the left can you use to describe that picture? So, for example, in picture A, we see, looks like, oh, I don't know, 5, maybe 6 little red circles that are there. So would we use the term atoms, or elements, or molecules, or compounds, or mixtures to describe that picture? There can be more than one correct. In fact, sometimes there's often more than one correct term. And then the terms will be used more than once. So I'll let you take a second, and I'll go through it, and we can kind of argue about the answers here in a second. So hit pause, take a look at the picture, think about it for a second, we'll come right back. All right. So here's your answers, your final quiz, and we're basically done. One more slide. So in A, picture A, I said that was pretty much atoms in terms of what it was. There's only one element present. So, you could say, hey, there's, for picture A, there's 5 atoms and only one element. For picture B, I called that a mixture. We haven't talked about that too much, but there's more than one different kind of thing that's present. So I'd say that's 2 different compounds kind of mixed up together in that particular container. We'll do more about mixtures later in this unit. For picture C, depending on how closely you thought those green dots were, I called it 3 molecules. One element's present, it's the green element, whatever that is, and so it's just one of those kind of diatomic gases like O2 would be, something like that. But that's 3 molecules of a single element. D, I called it just 4 atoms. Again, just taking a look at it, kind of like picture A, just a different element. E, again, is another mixture because there's more than one thing present, but they're not really glued together, and there's 2 elements present in there. For F, I have for that one, again, it's a mixture, but I've got a mixture of 2 different things. There's an element, just some atoms that are present, the red ones, and then there's a different little molecule that's present there, which is also an element, because it's 2 of the same thing stuck together, but they've got that diatomic green molecule, whatever that is. For part G, I would call that just a compound. You've got 3 different molecules. Each of those molecules contains 2 different elements, or 3 different atoms, however you want to say that. And then for part H, I would call that a mixture as well. And in this particular mixture, it looks to me like there are 3 different elements present. The blue element, the pinkish one, and the red one, all single atoms that are there. Over on the left, 1, 2, 3, 4, and 5, different ways that you could maybe apply those words to some of the different pictures. Again, we could argue back and forth about some of these, so don't take it too precisely. If you're off a little bit, you can always come and talk to me, and we can have a little discussion on that. All right, so here we go. At the end of this particular lesson, here's the types of things you should now be able to do. So you should be able to tell me what matter is, in the terms of that space takes up volume, all that. And you should be able to give me examples of things that are matter and, of course, things that are not matter. You should also be able to define these 4 key terms: atom, element, molecule, and compound. We use these all the time, so make sure that you have these pretty comfortable in terms of what they are in your head. You should be able to draw atomic level diagrams. Again, these are the little circle diagrams, so if I say draw an atomic level diagram of a compound or an atomic level diagram of 3 different atoms or 3 different elements, you should be able to sketch out some quick little pictures of that. You should be able to compare and contrast. This is an important skill in science, so you need to tell me how they're similar and tell me how they're different. But you should be able to compare and contrast an atom versus an element. The second pair would be an atom versus a molecule. The third one would be an element versus a compound, and then the fourth one would be a compound versus a mixture. This is probably the most difficult skill in this whole piece. If you can do this step well, you're in really good shape for this particular standard. And then if I've given you examples like literary pictures like on that last slide, you should be able to kind of give me some ideas about what sorts of representations there are, if those are compounds or elements or whatever. And then if you want to go a little bit further, if you got this and you want to take it a little bit further, you may need to look this up a little bit. How do we use the term molecule for certain elements when we typically use the term molecule for compounds? So again, that's more of a challenge question if you felt like you needed a challenge. So there you go. Thanks for tuning in. See you next time.